Quantum mechanics describes nature at its most fundamental level. It's the most precise theory we have to understand how nature works. So what we're doing is we're harnessing these unique and somewhat weird properties of quantum to allow us to create new technologies. Quantum computing is using the fundamental laws of quantum mechanics to allow us to compute in new and powerful ways. Computing with light as opposed to the standard approach, which is computing with electrons.
The Quantum Engineering Technology Labs at the University of Bristol is a whole load of people and a whole load of facilities that those people can use to do quantum technology development. So we've got labs like this one, for example, where you do what we call bulk optics, labs that do chip-based experiments, a clean room where you can go in and make chips, and labs where you can do really, really cold experiments. They're called cryogenic labs. Staff and students working here have various backgrounds. 70% of them, I would say, are physicists, but we also have electrical engineers, computer scientists increasingly, and mathematicians all working on different aspects of quantum engineering.
So part of what we're doing here in QET Labs is taking the world of quantum and applying it to things that are going to be really useful in industry and in the real world outside. One project that we're working on is a collaboration with Bristol City Council, the unique fibre optic network that runs throughout the city, and it enables us to connect our labs here to things like institutions and government buildings that we can use as a playground in order to test new technologies. We're able to check that our systems will be able to be used by people like hospitals and governments for keeping information secure. So it's this idea of making quantum relevant and useful to people who are going to be the end users. Although I don't consider myself a mathematician, it's the language of everything that I do. We use different maths in lots of different applications. One of the most rewarding things to do is to go in the lab and come up with 20 different ways of not doing something in search of the one which does work. That's when you're really training your intuition and learning. Quantum is a really interesting place to work. It's young, it's embryonic, it's not really clear exactly where it's going to go, but it has enormous potential.